All right, worksheet chapter 5, question number 1. We're going to complete the square so that we can put this equation in standard form and then graph it. All right. So the thing about completing the square is you want, this one might have completed the square twice in it because we have two variables that are squared. So the first thing we need to do is put our variables together that are the same. So for example, we want our x variables together. I don't need a space for that yet. 4y squared plus 16y. And then usually it's good to move the constant to the other side. Okay, the next thing is you don't want to complete the square with a values on your x squared, y squared terms of anything but 1. So you have to factor out any numbers that are there. So in this case, we need to factor out 25 out of everything that has x in it. So the reason I chose 25 is because I need the number next to x squared to be 1. So I take that entire coefficient out. So then what is 150 divided by 25? Yeah, so it's going to be a minus, because it's minus 150. So minus 6x. This is where I'm going to leave some space. I could go ahead and complete the square right now, but I'm going to finish writing this out unless you want me to just totally do that separately. I don't know. Maybe we should just go ahead and complete the square on the x, and then we'll go to the y. Okay, so at this point we ignore the 25. We half the negative 6. So take the half of negative 6 is negative 3. We're going to square the negative 3, so we're adding 9 to complete the square. The whole reason we do that is so that we can rewrite this as x minus 3 squared, and that gives us our h value, right? But we still have 25. And not only that, but the 25 out here means we're not really just adding 9. Well, we could, no, because we're adding the value of 25 times 9. So we can subtract that back out, or the easier thing to do, I think, is to add it to the other side, so it's affecting the number on the other side. So 25 times 9 is what, 225? So since it looks like we're adding 9, we're really adding 25 times 9, which is 225, so we have to add that over here as well in order to balance that out. I know it's tricky, you have to stop, you have to be conscientious about it, so you don't make any mistakes. Just be really careful. Okay. Next, I'm going to take the 4 out of the y values. So y squared plus 4y. I don't know if I gave myself enough space. I'll just move this. Okay. So then half of 4 is 2. So the 2 squared, which is 4, so I'm adding 4. So this is just like my scratch work, right? This is what I'm doing in my head. But you can show this stuff if you want, but it's not actually pertinent to the equation until we write out this stuff. Okay, so then instead of actually adding in 4, however, we are adding a value of 4. 4 times 4, which is 16. So we've got to add a 16 to that. So if we do negative 141 plus 225 plus 16, let's see, 225 plus 16 is 5 plus 6 is 11, carry the 1, that's 4. So 241. So then if we do negative 141 plus 241, that's nice. That's a beautiful 100. Yes. Yeah. Okay. So then I got ahead of myself a little bit, but this factors into 4 times y plus 2 squared. So I completed the square on my x's, and I completed the square on my y's, and now I have this equation, and I have 100 on this side. This is an ellipse, though, so I don't want 100 over there. I want 1. We're not going to subtract 99 to turn it into 1. We're going to divide by the 100 to turn it into 1, right? Because we also need those fractions for our ellipse form. So let's go ahead and divide everything by 100. now we reduce a little bit here. So 25 and 100 over 100 reduces to 1/4. That gives us x minus 3 squared over 4. And then 4 over 100 reduces to 1/25. So we have y plus 2 squared over 25. And then we got the 1 on the side like we want. We've got our standard form. We can fill our ellipse in standard form. All right, so now that would be done according to the test question, right? But according to our review question, it now wants us to graph. So I want to know where the center is. The center is using h and k, so we've got a -3, so that's a +3, and a +2, so that's going to be a -2. So there's the center of our ellipse, is the opposite of those numbers in the parentheses. So right 3 down 2, there's the center. Okay, and then a is the x value, so that's going to be the square root of 4, which is 2. So we take that number and we're going to count 2 in our horizontal direction to here and to here. And then we want to find b, which is going to be the square root of that number right here, so 5. So from our center, we're going to go 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. I don't think I made those the same size here. 1, 2, 3. That's probably somewhere like that. That gives our ellipse this shape. And the foci would be located in here somewhere. So we can go ahead and figure out what that is, just in case we ever needed to officially know. So C is the distance to the foci. So that would be found by doing, we wouldn't do a minus b this time because it's vertical. B is a bigger number than a, and we don't want to take the square root of a negative. So we're going to go 25, which is b squared, minus 4, which is a squared. So we get the square root of 21, which is 4 point something, right? 4 point-ish. I should have put my foci closer to this end. And that doesn't mean that the points themselves are located at a point that's 4, comma, whatever. That means that the points are a distance of 4 point whatever away from the center. And they would go in the same direction as the longest side of the ellipse. So since the length of the ellipse is up and down, the foci are up and down from the center. So there's our graph, and there's all of our numbers.